Good afternoon, learners. It's so good that I'm here today to share with you in these 2 hours one other concept in statistics. It is about the scatter plots. On the statistics section, remember this morning you had a discussion about other topics, concepts again in statistics. I'm sure the box and whisker and all other related concepts, quartiles, 5-number summary, and so forth. Now with the scatter plots actually allows us, if I may write down here, and I want you to also write down these as your notes so that we know exactly what scatter plots deal with. Allow us to compare, very important, I want to underline, 2 sets of data. You only throw a scatter plots when you have 2 sets of data. You must be careful that you have ungrouped data that you have dealt with. You also have grouped data that you have also dealt with in the topic statistics. But now on the scatter plots, you need to make sure that you have 2 sets of data or 2 sets of data. They must be 2. You can see that I underline the word 2. We'll make an example to check how do we deal with these 2 sets of data. With the scatter plots, we are also able to check the relationship now. With the scatter plots, they also make it easy for us to can check the relationship or correlation between 2 items or the 2 sets of data we are working with. Now, like I said that it is 2 sets of data. Be very careful that always with the scatter plot it is 2 sets of data. And with the 2 sets of data, when you plot the 2 sets of data, you are able to can compare the relationship or the correlation between these 2 sets of data. Plotting, I want you to write down some of these as of very important notes. Plotting on a scatter plot. Plotting on the scatter plot. Plotting on a scatter plot will again show us trends that the data displays to us. What trends do we get from the data? As you plot on a scatter plot, you will realize that a certain trends develop, which allows you to can make predictions in future, which allows you to better understand the relationship of these 2 sets of data. The trends that we are talking about, trends can be linear. Linear, now we know that it can be formed like a straight line. Linear, it can, let me just make a drawing here for linear. Linear, it can be trends that actually form what? A straight line kind of. You see that? Now see, the trend here is more of a straight line. You see now the trend is linear, a linear trend. But again, the trends that you can establish on a scatter plot, when you plot the points, they can also be quadratic. Quadratic. Now quadratic, what do we expect? Quadratic, we expect them to be more or less the kind of points that will be more or less what we know of a parabola to be. You can see that the trend here is more of a parabolic graph. Can you see the trend here? It's not linear. It's not a straight one like the one we have above here, but it looks more or less like a parabolic kind of graph. Maybe I should draw down here that this one looks more like what? Like more a straight line. Can you see that? Hence we say it is a linear trend. But this one, if you look at it carefully, you realize that it looks more or less like a graph that you normally call a parabola. So it becomes more of a quadratic kind of trend. And the last one that normally can come up is the exponential. Exponential. Now exponential, obviously we expect it to be more of an exponential graph. You see, we expect it to be more of what the exponential graph can give us. You see now, when you look at this one here, when you compare with the parabola, it is different from what we had on the parabola, but it looks more like an exponential kind of graph. Let's use a different color here. It looks more, the points here give us more of what an exponential graph can be. Now, already you see that with the trends, you are able then to can draw a certain line, whether it's a linear kind of line, whether it's a quadratic kind of shape, whether it's an exponential kind of shape. It means that on the scatter plot, I want us to write that down, on a scatter plot, we can also draw the line of best fit. We can draw a line of best fit. On a scatter plot, we can draw a line of best fit. And this line, very important about it, this line help us. The line help us, I wanted to write here, the line help us to predict the future. Predict the future. Already you can see that the future values or what might happen in future if the same trend continues and so forth. Let's look first at the linear trend. If we have this kind of trend, which we said is a linear, more informed by a straight line kind of, more informed like a straight line, you are able to can tell that with this line of best fit, you are able to can tell what will happen in future. What values will we get in the future if the same trend continues? What happens in the future? Will it happen that we come here? It is quite impossible. But the trend already shows that the other values will also be in the direction of already what the line of best fit is indicating to us. The same also go with the parabolic kind of graph, a quadratic trend. Already also it tells us that we cannot have in future going on, you cannot have values here. But chances are you'll have values going this way because already the trend has been established, which is a quadratic trend. Then the same goes with the exponential kind of trend. Exponential kind of, that line already tells us, it can clearly show to us that this is the kind of future values that we may have. In future, the kind of values is very unlikely that we will have values here because already the trend show us here that the values that may come in future should be the values that goes with the line of best fit because the trend already has been established. Now, very important, I think you also noted this down, that draw a line of best fit. Once you have established the trend, the points, plotted the points, draw a line of best fit, and you can see that with the line of best fit, it becomes very easy for us to can actually predict the future values. We are going to have an example where we demonstrate all this important information about the scatter plot. The first important thing is we need to make sure that we have two sets of data. And once we have two sets of data, then we will be able to plot. We will be able to plot the sets of data on the scatter plot. That's very important for us. Let's try to see if this example will assist us here. I will give you a set of data. Maybe we can all share here as we draw it. I will give you your own exercise to do in future. For now, let's look at this set of data, all of us. Let's say the set of data we have is this one. Here, I'll just make a table. Number of months. We'll write number of months there. And the other row is number of books sold. Books sold. The number of months and the number of books sold. Now the example, if I may read to you, it says, consider the following scatter plot of information obtained by a publishing company that recorded the number of books sold over a period of 12 months. So it means we have 12 months here. I hope they all fit here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, doesn't fit very well. I'll draw another one here so that we fit all the months in. It should be 12 months. You see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. It's better this way. It is better this way. I'm sure we are all looking at this. The number of months, the 12th months, the 11th month, the 10th one, the 9th one, the 8th one, 7, 6, 5, 4, 3, 2, the first month. And we said on top here is the number of what? Number of months. I'm sure everybody can see that, number of months. And at the bottom here we have number of books sold. Books, these are the sold, the books which are sold. I'll use a different color for the books sold. Now the information we have is here says, on the first month, the company sold 10 books. Can you see that? On the first month, the company sold 10 books. On the second month, the company sold 22 books. On the third month, it sold 20 books. On the fourth month, it sold 38 books. On the fifth month, it sold 46 books. On the sixth month, it was a very good month for the company. Around June, the company sold 100 books. On the seventh month, 48 books. 62 books on the 8th month. 61 books on the 9th month. 74 books on the 10th month. 88 books the 11th month, and 86 books on the 12th month. Now when you look at this, already you can see that we have two sets of data. Remember the data above here, it is the number of months, the months, number of months. The first month, the second month, the third month, the fourth month, and so on and so on and so on. And below there, the second row, we have the number of books sold by the company. Now let us agree, we have here two sets of data. Now once we have two sets of data, what we should do with it, we can then draw a scatter plot, because we said the scatter plot normally we use it when we have two sets of data. And here we have two sets of data. You can see it is the number of months. The number of months is the first set of data, and the other set of data that we have there is the number of books sold. Now we need to place this information. We need to put this information on the scatter plot. We are using our graph paper here. Just follow with me. We need a graph paper to do this. Now on the graph paper, we are going to draw here. The highest number we have is 100, so it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm sure that will be 13, 14, 15, 16, 17, 18, 20. Let's see how will it look like until there. We draw a line like that, right? And then we are going to do our scatter plot now. And then we draw another line like that, a horizontal one. We can have here 1, 2, 3, 4. Let me check if that will be fine. Let's try it here. Let's use this one. 1, 1, 2, 3, 1, 2. There we are. 1, 2. There we are. 1, 2. 1, 2. I'm trying to keep the same interval in between. 1, 2. There we are. Right. So always now the information on the scatter plot. Maybe I should come back here. Always on the set of data given to you. Do you see a set of data given to you? Always just consider this as your x-axis. Treat it as your x-axis. And the bottom row, just treat it as your y-axis. The first one, row, you can just treat it as your x-axis. And the other row, the bottom, the second row, you can just treat it as your y-axis. This will mean that on the y-axis here, what do we have? If this is x and this is y, on the y-axis here, what we have is the number of books sold. Number of books sold. Are you happy about that? This side, we are going to have the number of books sold as our y-axis. But the horizontal line, this one now will be what? The number of months. The number of months. The number of months. Let me use a different color. This one is trying up here. The number of months. Now the number of months, what do we have? We have the first month, I'll write one there. We have the second month, the third month, the fourth, the fifth, the sixth, the seventh, 8th month, 9th, 10th, 11th, and the 12 months. Are you happy with that? Those are the number of months. And this is the information from the set of data. Look at the information. The number of months, we take that information. That information come here. The number of months. Remember I said we just treat the first row as the x-axis, the second row as the y-axis. Now the number of months is 1, 2, 3, 4, 5, 6 until 12. And the vertical line, which is the y-axis, we treat it as the y-axis. Where is that? The y-axis. Now it will be the number of books sold. So we can just keep an interval here because to capture all the books sold, we can just have an interval maybe of 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, we have somewhere there 100. Good. That will be the number of books sold. Remember, we take this information from the set of data. It is two sets of data. The number of months, we are going to compare it with what? With the number of books and establish the relationship as to how the months relate with the number of books sold. Now, when you look at the information you have, the first month, how many books were sold? It was 10 books sold. Do you agree with that? Now, on our scatter plot, this is what we do. The first month, it was 10 books sold. Do you all agree with that? First month, 10 books sold. Can you all see that? Good. And the second month, maybe I should keep the information here. The second month, how many books were sold? 22 books. Good. So the second month, here we are. The second month, how many books were sold? Can you see my hand there? Second month, it is 22 books. So 22 is just there. A little above 20, 22 books were sold there the second month. Can you see that? Right. We always refer to our set of data. The third month, how many books were sold in the third month? Let's check there. Books in the third month is 20. Do you all agree? The third month, number of books sold in the third month. Look at my hand. 20 books. The third month, 20 books. We establish the relationship between the number of months as well as the number of books sold. Can you see that? The relationship, how do the two relate? Good. And the fourth month, how many books were sold? 38 books. 4 is 38. Look at my hand. 4 here. 4, it goes to 38, 35. 38 would be somewhere there. The fourth month, somewhere there is 38. Can you see that? The fifth month is 46. Fifth is 46. There we are. Maybe I should use a ruler so that I'm very accurate. The fifth month, can you see the ruler makes things much easier for me now? Month number 5 is 46. Here is 45, so 46 is just a little above 45. Do you agree with that? We are representing our information now on a scatter plot. The sixth month is 100. There is 6. Can you see 6? The sixth month, here it is. It goes up, straight up. 6 goes straight up. it goes to 100. The 6th month, we have 100 there. Can you all see 100 there? Up. The 6th month goes to up there to 100. And the 7th month, we continue until the 12th month. Ne? On a scatter plot, the 12th month, the 7th month, I'm sorry, the 7th month is 48. 7, it goes to 45, 46, 47, somewhere there is 48. The 7th month, good. And the 8th month, the ruler makes things very easy for me to plot my points. The 8th month is 62, 8, and then I go straight up to 62. Here is 60, and 62 will be somewhere there. 62 there, good. And the 9 month, I'm sure you are all following. The 9 month is 61. Books, 9. There we go. We are looking for 61. Here is 61. I hope you are following with me. I hope that is very accurate. The 10th month, we continue. I'm looking at the set of data given to us. 10 is 74. 10 goes way up, up to 17. 75, it means 74 comes just before 75. The 10th month is 74. There we are. The 11th month, good. 11 is 88. There we go up to 80, 85, and 88, if I'm accurate enough, 88 becomes there. And the 12th month now, the last month is 86 books. The last month is 86 books. There we are. I need to be accurate. A ruler makes things much easier for me. 12, it goes to 86. 12 goes to 86. 86 is just a little above 85. There we are. Good. This is what we have drawn. This which we have drawn here is what is called then the scatter plot. We have used two sets of data. We are trying to establish the relationship between these two sets of data. You see the two sets of data. We had to make sure that each and every month above, we plot it accordingly with the set of data below, the second row. First row is matched with the second row. And once you do that, here we have our scatter plot. And you can see our scatter plot covers all set of data we have here. Now already when you look at the set of data, look at this set of data. I'm sure from the trends we talked about earlier on, I'll bring you back the trends we have talked about earlier on. I'm sure when you look at the trends we mentioned earlier on, you can already begin to think of a certain trend. We said the trend can be linear, remember? The set of data can make a linear kind of trend, or the set of data can make a quadratic kind of trend. Do you see the points now? They can also form a quadratic trend. I want you to note down this as your very important notes. It can be linear. I want to bring back linear again. The set of data can be linear. The set of data can be quadratic. The set of data can be exponential trend. Do you realize that? Now let's look at what we have in our case here. Look at this. I'm sure already you can tell that this set of data is giving us some information in terms of the trend. And we can see that the trend that is established by a set of data here is more of a linear trend. Do you agree with that? The set of data here is more of a linear trend. But we also need to realize that there is another point out there. And I already can hear you talking about that point, that no, that point is an outsider. Outlier by the way. That point is an outlier. Look at this one point. This one point is standing there out of the trend. It is just standing there alone. That point is standing there alone, the outlier. You see our trend, which is a linear trend, all sets of data here, they give us a linear trend. I'm using a ruler for that purpose. Do you see a ruler now? A linear trend, good. But you realize that there's this other point which is way out of the trend we have here. And of course, you already know that that point then becomes an outlier. And normally, if we have information that we deal with, we normally ignore the outlier, because outlier obviously standing away from all the other points we have. We don't necessarily take it in as far as interpreting the trend we have or interpreting the information we have. Normally we'll just note, but we need to be very aware of it. We need to know that that point which is away from other points, I just want to write it down here. That point which is away from all other points, outlier, it is an outlier. And you see I've used the red color as I used the red color for that point. That point there which is out there, it is normally called an outlier. This is the scatter plot. And it's very important for us to be able to draw it. It's important, very important to draw it. And you can see the relationship between the month and the number of books. The first month it was 10 books. The second month it was 21 or so books. Can you see that? The third month it was 20 books, and so on. Now already we can see when you look at this trend that on this trend it looks like the first month the bookshop or book company, publishing company here sold only 10 books. But as the months increases, more and more books are sold. It looks like people are getting to know about this publishing company. More and more people now like these books. So more and more people are beginning to buy the books. Look in the third month. The first month, we said 20 books were sold. Can you see that? Month number 3, 20 books were sold. Can you see that? But when you look at the 10th month, you look at it here, and when you look at the 10th month, you see that a lot of books there were sold. There it is. Around 74 books were sold in the 10th month or so. Now that becomes the information we have on our scatter plot. I'm sure everybody is happy with that. Here's the 10th month, 10, 10, 10, 10, 10, 10. A ruler makes things very easy for us. You put a ruler there. You can be able to read the information. 10 is how many months? It is so it becomes 74 books were sold on the 10th month. The scatter plot, this is what we have drawn here. Good. I said always the outlier, you need to also show it. Show the outlier. There is the outlier, but it's fine. It doesn't disturb us from checking for the trend. We can see, but the trend here normally is a linear trend. As the more months come, more and more books are sold. The number of books increases. The 7th month, number of books 48 or 47. By the 10th month, there it is more books, 74 books are sold, and so forth. Good. Now, for us to draw the line that we're talking about here, the line of best fit, because we have the trend. Remember we said in our notes that we cannot draw the line of best fit. Let me put back the notes. The line of best fit help us to predict the future values. What will happen as in the following months in as far as selling the books by the book company. Now the line, that red line that we drew there, the line of best fit is the one that assists us to predict the future values. Now for us to draw this line of best fit, we are going to use a calculator. And I want all of you, please every one of you, take out a calculator, because there is no other way that you are going to use to draw this line of best fit, because we need to draw a very accurate line. We must draw a very accurate line. We have seen that the line might be a linear line, a straight line. Now we need to be very accurate to say how will our line of best fit look like. The line of best fit, because we are going to be accurate, let me write down here. Now we are going to draw line of best fit. Good. Now for us to draw a line of best fit, because it is a very accurate, I want to write here accurate line. This line, because it's so accurate, it is called the least squares regression line. That line of best fit is called the least squares regression line. Now the least squares regression line, obviously because it's a linear line in that case, will be a line that will be having this kind of an expression. I'm sure there is this expression you are familiar with. Remember, we always dealt with the straight line, which we had the formula for the straight line as this formula here. Now, because in this case, it is the least squares regression line, it will be obviously having the gradient. You remember with the straight line, B will be, let me write it down here. B is your gradient. The value of B becomes your gradient, and the value of A is your y-intercept. I'm sure you remember what we have learned about the straight line. Remember the equation of the straight line, there it is on the small box up there. Now it is actually having the similar structure, the least squares regression line. Y is equals to A plus bx. Now we are using the values a and bx in this equation here because you will see that on the calculator, this is the values that the calculator uses, the symbol that the calculator uses. You will see that it uses a as well as b. B, it is bx, meaning b is the gradient. B is our gradient. Good. Remember what is important about this line. We said we use that line to predict the future values. Good. Now everybody, I'm sure you have a calculator now. Everybody have a calculator. I'll try to put mine here. I'm using a Casio calculator in my case here. Now I've pressed it on. My calculator is on. We need to have the values, the set of data. We need that set of data because we are going to punch the set of data in the calculator here for the values we need. We need a set of data. I'll bring it back for you. Here we are. The set of data. Do you have it there? There it is. Good. Are you happy about the set of data? The months as well as the number of books sold. That is the set of data we are going to punch in our calculators here. Now on our calculators, I'm sure we go mode. Can you all see mode? And there's 2 there, which is stat. I press 2 again. And again, I press 2 because when you look on the screen of your calculator there, if you are following me, on the screen there, it says A plus BX. Remember, that is what we are looking for, ne? A plus BX. So I press 2 because 2 is A plus BX. It gives me 2 columns. The one column, it shows the X, and the other column shows the Y. Remember? And the X, you said, is what? Is the first row of set of data. So on the X column on the calculator, I put in 1, and I go is equals to 2, is equals to 3, is equals to 4, is equals to, I always press on my calculator. And you can realize that those that I've just pressed in are the numbers that comes from the first row there, which we said we'll just call it the Y or the X row kind of, right? 4, then you go 5, and I say is equals to on my calculator, 6 is equals to 7 is equals to 8 is equals to 9 is equals to 10 is equals to 11 is equals to 12 is equals to. Very good. There we are. You see, we have entered all the numbers that we had on the first set of data there. Then I move my cursor on the right column. I'm pressing now to go to the first value on the Y column now. The Y column, the first value on the Y column. I moved here on the calculator. You move now to the second column, and now I went up, 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 up until I go to number 1. Now you can see now on the X I have 1. Now on the Y I must enter how much? 10 is equals to 22 is equals to 20 is equals to 38 is equals to 46 is equals to 100 is equals to 48 is equals to 62 is equals to 61 is equals to 74, is equals to 88, is equals to 86, is equals to. Good, there they are. We need to be very accurate. Remember now on the calculator, we cannot afford to miss any number there because now it won't give us the correct information we are looking for. Good. Now thereafter now, we can now have the x values as well as the y values. After pressing now the x and the y values and they relate very well, we are on the 12th value. X is 12 and y is 86. I can see that on the screen of my calculator. I go AC on my calculator. Now when I press AC, it shows me 0. Good. Then I go shift 1. Shift 1, you can see there we have shifted to state again. Shift 1. Now number 5. You see there's 1, 2, 3, 4, 5, 6 on your calculator. Number 5 is where we are going to look for regression. And it is written here on the screen. Number 5, the 5 is written on the screen. I press 5 is regression. Look what happens now. When I press 5, the screen here shows me A, B, R. There is the bar X kind of and the Y bar Y kind of. But we are interested on the A, the B, and then the R. We'll talk about the R later on. But we can see the A as well as the B. And remember we said on our equation for the line, we have A as well as B. And here they are. They come out in the on the calculator. They come out on the calculator. Here they are, A as well as B. Now when you say A is 1, we press 1 on the calculator. I'm now pressing 1 on the calculator. It gives me A there. I say is equals to. How much is A? Now A here, I write it down. A, the value of A, my calculator say here it is 10,9697. The value of A 10,969697. Good. Then I go AC again, and then I go shift. Remember 1. It shows me 5 is regression. I press 5. I'm looking for the value of B. B is 2. I press B is equals to. Now I also write the value of B now. The value of B, the calculator says 6,7097,9021. That is the value of B. Now already we agree. Look at this now. The equation of our regression line, the line that we are going to draw, the equation now is y is equals to A is 10,96969697 plus, do you agree with me? Bx, the value of B from the calculator, 6,70979021x. Do you see that? That is the equation of the line we have here. Now normally our question papers will say correct your values to 2 decimal places. Do you understand that? Correct values to 2 decimal places. Already you are looking at this and say, but this equation will be y is equals to 10,97. Do you agree with me? 97 plus 6,71x. Are you happy? This is our equation. You can see it is A plus bx. Y is equals to A plus bx. So this is the equation of our line, the least squares regression line. This is the equation of that line. Remember we said we need to draw that line, but before we draw it, we must first get the equation of the line. Are you happy with that? Good. So it means on our scatter plot here, look at the scatter plot. We have not drawn the line as yet. Do you realize that? We first had to get the equation of the line, and we used a calculator to find the equation of the line. It's a very easy process. I'm sure you can repeat it again on your own. And the calculator will give you the values to say, no. The equation of your line becomes y equals to 10.97 plus 671x. Good. Now we continue now to see if we can draw our line. Now, for us to draw the line now, we have now here, on our calculator, I put this value here. I put this value here for us to draw the line. It is 10.96969697. We say plus 6.70979021. Do you agree with that? 21. I'm sure we are very accurate on our calculator. 21. Now, after putting in that value, what do we do now? We look for the value of x on our scatter plot. That when we substitute and we check how much will we find for y, how much will be the value of y. We wrote all this. Now we look for the value of x, that when we substitute this value of x, how much will be the value of y. We can now look at our scatter plot. I want to bring it back. The value of x, remember we said this is the x row, am I right? The x line, the x-axis kind of. Do you see that? We take this value of x, we can just say 1. Let's take 1 and we substitute 1 for x here. Now it means on this calculator we say brackets 1. It means for x we are putting in 1. We want to check if x is 1, how much will buy? And we say is equals to. Good. Now it means we have, if x is 1, I'm writing down, if x is 1, why the calculator say it will be 17.67 or 70. There it is. There it is. If x is 1, we put it into the equation there. If x is 1, then y is 17.70. So it means that now on our scatter plot we come and say if x is 1, y is 17. Here is 17 somewhere here. Y is 17. Good. You see that point? Right. We are going to take any other value again here of x. We take a value somewhere there at the bottom and a value somewhere there at the, up there on our axis so that we can draw the line. Now we go back to our calculate and say delete. Where x was 1, now we are putting on, let's say x is 10 for instance. If x is 10, we want to check how much will be y. If x is 10, there we are. We want to check then how much will be y is equals to, y becomes, calculator says 78, comma something. Calculator says 78, 75, there we are. 78 is somewhere here, 78 somewhere there. Good, there we are. Now, here we are. Remember we took the value of 1, we put it into, substituted it into the equation here for x. Where there is x, we substituted 1. Do you see that? Good. And we found the value of y is 17.70. And then the other value, we substituted 10. Let me write it down here. When you put 10 for x we put in 10, and what we get there is 78, 78.07. Good. If x is 10, then y becomes 78. Where is that? 10. We used 10. Here we are. 10. 78 point. There we are. Good. There we are. Right. Now we use now the 2 points. We join them. We join the 2 points. Here we are. We use a ruler to join the 2 points. There are our 2 points. Now we have drawn now the line of best fit. We have drawn the line of best fit. You see, it's a very accurate line. We have used the equation. We have used the equation here that we found from the calculator. And from this equation now, we have drawn the line of best fit. There becomes our line of best fit. Remember we said, what did we say about this line? We said this line is a very accurate line. It's called the least squares regression line. Accurate because we can now use this line to predict the future. We can use this line to predict the future. What do we mean by saying so? We are saying if you have this kind of line, you say the 12 months Remember our information, the 12 months, you had so many points. But now, what will happen on the 13th month, the 14th month? The 13th month, how many books can be sold? We don't know, but we can use the line to predict that information. The 14th month, how many books will be sold? We don't have that information, but still we can use the line to predict how many books will be sold on the 14th month. Let's just quickly do that. Remember the line, our line, I'll just use this other color. The equation of our line, very important equation, y is equals to 10.97 plus 6.71x. Now, if we want to know how many books, let me write it down here. How many books will be sold on the 14th month? Do we have the 14th month on the information given to us? No, we don't have the 14th month. We are only given months until the 12th month. We don't have the 14th month. But we can use the line now. Here is the equation of the line. We can use the equation of the to predict about the 14th month. So it means we will have y is equals to, where's that other color? Y is equals to, we have in 10.97 plus 6.71. We are looking for the 14th month. You see now for x, we are substituting x with the 14th month. So we just go to your calculator here. On your calculator, you just go there, you insert everything and the 14th month. And how much do you get? The possibility is, because this is an estimated value, look at the sign I use now there. The estimated value is you may sell 104.91 books, which is because the number of books, it can be 104 books. It can be 104 books or it can be 105 books, it depends. But because the number of books, we can't leave it as 0.91 because now the number of books need to be a standing unit. 104, but it is an estimated value. Look at that. It is an estimated value. Our line agrees with us. Our line says from the 12 months, you're still going up and up and up. You are not going down. The line can show us that the trend is a linear one and the trend is actually going up. The more months increases, the more books are also sold. So it will be more, which is 104 books that may be sold. It is very important for me that before we can go on with many other exercises, that we are sure that we understand what you talked about, that the scatter plot, you need to have two sets of data. And once you have two sets of data, you plot your set of data. You plot your set of data, plotting your points. 4 months goes with how many? 38 books. Can you see that? 38, the 4th month, there it is, and so forth. You plot your set of data. But for you to draw the line of best fit, since it is going to be a very accurate line, you need your calculator. And from the calculator, you must first find the equation of the line. And we went through the procedure of the calculator. It will give you the value of A, the value of B, which is the gradient. Here it is, value of A, value of B. You substitute it in there. And to draw your line, you substitute the values of X. These are the values of X in the line here. And it will give you which value are you going to get for Y. This is the value of X, and this will be the value of Y. Do you see that? Now, once you have those, you put them, and then they assist you now to draw your line of best fit, which is the least squares regression line. It's a very important procedure, and I'm sure you have all been following it. Good. We will have an example where we are all going to work on it to do the same kind of exercise. But before that, on your calculator, if you go, I think, AC, remember your calculator is still on. If you go AC, and AC you see shift, stats, and remember you're working with 5, and 5 is regression. I press 5. We have used the value of A, we have used the value of B. But can you see there, number 3 is R. We need to talk about R. Number B is R. We can now talk about R. Now, R is the correlation coefficient. R is the correlation coefficient. The R value tells us about the strength of the relationship. How strong or how weak is the relationship of our points? Look at our point. Do you see our point? Now R must explain the strength of our points here. How strong or how weak, for instance, or moderate is our points. I want to write it here now. Correlation. You see it is there in the calculator. Correlation. The symbol for correlation is R on your calculator there. The symbol for correlation is R on your calculator, and it tells us what? The strength of the relationship. The relationship we have on a scatter plot between the two relationship between the two variables, if I may say, sets of data. The relation between these two variables in a scatter plot. So for R, you must have a scatter plot. You must have a scatter plot. You must have, here it is the scatter plot. Now R will tell you the strength of the relationship. We'll talk about that. Now the strength means what? It means how close the data points are to the line of best fit, which is the least squares regression line. Line of best fit, in this case the regression line. I'm writing it here down, the regression line. How close the points are to the line. Look at these points. R will tell us how close are these points towards the line. How close are they towards the line? This is the value of R. R will tell us that no, these points are very close or to the line, or these points are not so close to the line, or whatever. We'll talk about the R, how does it relate now to the line. But the intention of R on your calculator here, because there's still R there, on your calculator, the intention of R is to tell us how close are the points to the line. Good. Now let me just press here for the exercise that we are doing, that R is 3 and I'm pressing 3. There it is equals to, so the value we get for R is equals to 0.83. There it is. I've just corrected it to 2 decimal places. So R is 0.83. Good. Now we need to talk now about R. What does it actually mean now? If R is 0.83, what does that mean? Let us look at this. Right. Good. Let us look at this set of points. It's the scatter points. Ne? Look at them here. Right. Can you see that in this case, R is giving us 1. On the calculator, when you press the calculator, R is equals to 1. Exactly 1. Look at it. The point, look at how points are assigned here. The points, R is equals to, what does that mean? That means that we have a perfect positive association. I want to underline these words. Once R is 1, perfect positive. Those two words must go together. Always when you talk of this association of R, the correlation coefficient, you must use the 2 words becomes very, very important. Perfect positive. Do you see that? Now, why do we say positive? Remember your straight line graph, ne? I'll just draw it here. Every time if the line is like this, then we know that we have a positive gradient. Do you remember that? The gradient is always positive. That is why here we say perfect. It is perfect. The points are just perfect on a straight line, but they are positive. Do you see that? Perfect, positive. Good. I want to keep this as your notes, that you really keep this as your notes. But if R can give you a -1, when you press on your calculator there and R says -1, look at how does your point look like. Remember your straight line again. I want to remind you about that. If your straight line was in this form, then you also knew that your gradient is negative. Your gradient was negative. I want your teachers please to explain this again to you when you are doing straight line graph. When you are doing straight line graph, the x-axis, the y-axis, when do we have a positive gradient and when do we have a negative gradient? Now, if r is negative 1, two ways again. Can you see in this case now? It's again very perfect. Do you see perfect again coming out? Perfect. But how is this perfect? Perfect negative association. Perfect negative and perfect positive association. That's how you explain your r. If r is equals to 1 and if r is equals to negative 1. Look at this set of points now here. Here. On your scatter, look at your scatter plot. Do you see your scatter plot? R is anything as 0,9. Do you see that? 0,9. So 0,9, 0,8, 0,7. I write it here 0,8, 0,7. Do you see those? Maybe 0,6 as well. 0,6 as well. All those will give you what? Strong positive. I said it is always two ways. Please keep that in mind. It is always two ways. Strong positive. If 0,9, then it means we have what? Strong positive. The movement is that a positive gradient movement. Can you see that? The positive gradient, positive. But in this case, negative 0,9. You see that? Look at the movement of your gradient now. It is again what? Strong negative. Here it is. Here it is. Strong negative association. I said it is always those two ways that are very important. Strong negative. Good. I'm going to leave these notes here. I want you to look at them. We're having a short break, but look at those notes are very important. And remember that when you talk of R, the correlation coefficient, you need the two ways. Perfect positive or strong positive. You can see at the others weak positive or weak negative. We'll talk about that, but I'm leaving them here on the screen, and your textbooks also explain them very, very well. But this is the very important notes that you need to have. Let's have a short break. We're coming back after 5 to 10 minutes. Thank you. Yes, good. Welcome back. I'm sure you had enough time to talk about the strength as defined by the correlation coefficient. Here is a part that I really want you to keep as your notes. It's a very important part, this one here. Remember that this is telling us about the value of R. The value of R which comes from the calculator. From the calculator here, you get the value of A, the value of B, as well as the value of R. Now the value of R here is explained to say if it is 1, if the calculator says R is 1, then you know that the relationship or association we have there is a perfect positive. Perfect, it's very perfect. Or perfect negative. Do you see that? This is strong positive. You always need to indicate whether positive or negative. That is very important. That's why I said those two ways becomes important to explain R in this kind of questions. Always need to tell whether it's positive or negative. Now positive, you see, it goes with the gradient of a straight line. It's a positive direction. But this one here is a negative gradient. You see that? It's a negative gradient. A negative 0,8, 0,9, it's a strong negative. Do you see that? 0,9, here it is. A strong negative. But now when R is 0, look at these points. Remember, this is your scatter plot. You have plotted the points here. Look at those points. They don't tell you of any relationship between the x as well as the y. It doesn't tell you of anything. So it says no correlation. There's no correlation at all. Do you realize that? But when you look at this one here, 0,1, 0,2, here it is here. Weak positive. You can still see the positive kind of movement there. Weak positive. But here we have a weak negative association. Weak negative association. Good. I want really that you note down this. It's very important notes that you need to have. Two words all the time. Two words all the time. Look at this. Moderate, moderate negative, moderate positive. Here it is, 0.5, 0.6, moderate. It's not that strong. This one is strong positive, moderate positive, a very weak positive. The positive thing, you can still see it. The negative part, you can still see that this trend here is a negative kind of. So you need to always tell whether positive or negative. But here, really, there's no correlation at all. We can't tell about it. We cannot even make the prediction about what we have here. I'm sure we cannot even have any regression line here, because remember, regression line is the one that assists us to make predictions. But if there's no correlation at all, the two items, the two variables do not relate at all. Good. I want to now remember now what we had from the exercises that we are doing, all of us doing. We said R is 0.8. Check from your notes. What does that mean now? If we have to define the association as 0.8, it means we have a strong, I'm sure you all agree, strong positive. Strong positive. Why? Because R is positive. Ne? But if it was negative, it was going to be strong negative. But here it is a positive value, so it is strong positive association that we have in this exercise that we're doing here. Remember the one that we're drawing, all of us, this one. We have the line. Now from the line, we checked for R correlation coefficient. We are able to can explain the correlation coefficient strong positive in this case based on the nodes we have there that explain the correlation coefficient. Good. I want us to work on this exercise on our own. It's an easy one. It's a very easy exercise that I want us to work on. This is the exercise. Look at it. It's question 5. It's written question 5. It's a question that comes from one of the exemplar papers in 2008. Question 5. I want to keep it on the screen. First, let's talk about it. I'm not writing anything. Let's all look at the screen. Let's look at this question. Do we have two relationships? Two. Can you see two there, variable, two items? Yes. The first one, annual advertising expenditure. And you see this noted there with X. Annual advertising expenditure. The second one, annual profit. If you spend 12 Rand, the profit becomes 60 Rand. The question, the owner of a Star Travel and Tours compiled the following data which illustrate the relationship between the annual profit of the business and its annual advertising expenditure, and both are in rands. Those both are in rands, money. Now it means that if you spend 12 Rand on advertising, the profit becomes how much? 60 Rand. Do you agree? If you spend 14 Rand, the profit becomes 70 Rand. And so on and so on. I want you to look at the table. Question 1 says, plot a scatter diagram for the data. We just plot. Let us not plot for now. Look at the table first so that we are here. It is two variables that we have that we are working with. The first one, annual advertising, it says it is X, and the second one is annual profit is Y. So we agree. Always on top is X, and then the other one is Y. Good. The question there it is. I'm going to suggest to you that let's draw the scatter plot. Let's draw the scatter plot. I'm suggesting this as your intervals. You can just use your ruler and draw this. We will go back to the question. Let's just first for now draw the scatter plot. This is, I'm using a graph paper here. You can use your ruler, try to be very accurate. This is your scatter plot. I'll keep quiet and give you time to draw the scatter plot. Yes, are you all happy with what you have drawn there? I said use a ruler because this should be very, very accurate. Let's go back to our question. There is our question. Plot a scatter diagram for the data. So on your scatter plot there, what do you have? Your axis. The horizontal one is what? Annual advertising. I'm writing it. Advertising. Annual advertising expenditure. Expenditure. Good. And that one, the vertical one, remember the Y one now is annual profit. So you need to write the annual profit. And this, all these are in rands. Remember, we are dealing here with rands. Let's check now. You see now it's written now that this one is annual advertising expenditure, and this one is annual profit expenditure. If an annual profit that you get from the expenditure that you have made. Good. This information, we simply take it from the question itself. Can you all see the question? Annual advertising expenditure, what you spend to advertise. I spent 12 rand. Or the company here, Star Travel and Tours, spent 12 rand. What was the profit? Annual profit was 60 rand. Now plot a scatter diagram. I'm leaving the points on the screen for you now to plot them on your graph paper there. Remember, I said the ruler sometimes help you a lot to actually draw this properly. Let's draw now. It says 12 there. 12 give us 60. And then 14, 70. 14 there, 70 rand, 70 rand, 17, 90 rand, 17, 90 rand. I'm sure you are all checking with me. 17 is 90 rand. And then, I hope I'm corrected, 21 is 100. 21 is 100 rand. 21 is 100 rand. 26 is 100 as well. When you spend 26 rand, you also again get 100. Good. 26, and then 30 is 120. 30 is 120. 30 is 120. Good. There we are. 120, 30. The question said, plot the scatter plot. Plot the scatter plot. I'm sure you did. Now, when you plot the scatter plot, realize what happens, because there's a question here. Do we include an outlier when determining the equation of straight line? Yes. When you draw the scatter plot, you draw based on all the information you have. Every single piece of information you have here, you include it when you draw the scatter plot. Is it okay? Even when you go to the calculator now to calculate the equation of the least squeeze regression line, when you draw check for the variables of that equation, the values of that equation, you include all the points. You include everything. I don't even say even with the outlier, but you include everything in your calculator. All the points, you include them in there. It's only that on the scatter plot, you'll notice that, but that one point is too far, it's an outlier. Just to notice that at least there's an outlier here. But when you do every calculation, you include all the points. All the points are included. I want to emphasize that one. Good. Your scatter point, I don't know, it might look more or less like this one. Yours might be more accurate. Remember, we are gunning for accuracy here. You need to be very, very accurate. 14 rand, or was it 12 rand? I think 12 rand gave us 60 rand profit. 14 rand gave us 70 rand profit. Do you see that? 14 goes with 70 rand. And here 12 rand goes with 60 rand, and so on and so on. And I'm sure when you check with the ruler there, it makes your work to be more accurate. Look at the 30 rand. 30 rand, it goes straight toward 120 profit, 120 profit. When you spend 30 rand, you get 120 profit. Good. Now we are happy with our scatter plot. We have drawn it. There it is. Good. Now question 2 now says, calculate the equation of the least squares regression line for the data. It needs us to go to the calculator now. We need to definitely go to the calculator for this one. Calculate the equation. Remember now on the calculator, the first thing we do now is what? We say on, it's fine, mode, and 2 is statistics, 2, and 2 again. Can you see it is A plus BX? Y is equals to A plus BX. You note that down. You write it down. The calculator shows you that 2 is A plus BX. I press 2 on the calculator. It gives me 2 columns, X and Y. Do you see that? Now I enter my information or the data now. The first one, I start with the row up, the row above, which is the X one. It is 12 is equals to, you'll help me there, 14 is equals to, 17 is equals to, 21 is equals to, 26 is equals to, 30 is equals to. Good. I have 6 pieces of data there. 6, my calculator show me. I shift to the other column, which is the Y column. I move my cursor up and I check on the table. It is 1, 2, 3, 4, 5, 6. Good. It means I have all the data required. I am now on the Y, annual profit. The first one is 60 is equals to, 70 is equals to, 90 is equals to, it's 100 is equals to, again 100 is equals to, and the last one is 120 is equals to. Good. They are now all in the calculator, both columns in the calculator. Check your calculator there. They are both in the calculator. Now you go AC on the calculator. AC, your screen now becomes 0. Once the screen becomes 0, you go shift and 1. You can see shift at 1 day starts again. Shift and 1. Now 1 will show you 1, 2, 3, 4, 5, 6, but 5 is where we have the regression. Now I press 5. Now can you see that A, number 1 is A. Remember you're looking for the equation of the least squares line for the data. A, I press 1 for A is equals to, now it says A is equals, I write that value now. I write that value down. A is equals to 30,650,4065. Good. And now I'm looking for the value of B for my equation. Right? I go AC on the calculator, shift 1, again 5, and then 2 is B. Do you see on the screen of the calculator that 2 is B? I press 2, it gives me B, and then B is 2,967,479,675. Good. Now in that way I can write the equation now. A is 30,6. Now I can write the equation. The values come from the calculator. Here are the values from the calculator. I now write A is 30,650,4065. It's plus. B is 2,967,479,675. X. Remember, it's A plus BX. Do you see that? X, there's X there. But the question will always say correct it to 2 decimal place. Is 30,65. Do you agree with that? Plus 2,97x. That is the equation of your least squares regression line. The equation, and you can see already the gradient of the equation is positive. So it means even when you come to your R, you expect positive association. Positive, because already the gradient is positive. Good. We have answered that question. I'm sure everybody is happy. This comes from the calculator. Good. Now, the question now says, draw the least squares line for the data. Draw that line. Draw the line. Now, remember now when you draw the line on our scatter plot, maybe we should go back to our scatter plot. On our scatter plot, we need to draw the line. We don't just draw the line. But remember what we suggested, that on this equation of yours, we are going to substitute the two values for x and see how much do we get for y. Are you happy with that? We are going to, on the calculator now again, I put in our equation 30.6504065 is plus 2.967479675, and I'm saying brackets. Now I'm putting the value of x on the calculator. I check my scatter plot and I'm saying, no, for x, let me take any value, let's say 10 for instance. Let's say 10, do you see that? For x, any value at the lowest and one value at the highest there. For x, let's say 10. We put 10 into our calculator, close brackets. We want to check if we put here, if we substitute x with 10, if we say x is 10, how much will be the value of y? We say is equals to, it gives me the calculator 60,33 for instance. Good. If x is 10 and then y is 60, that. Now I also check, let's take another value of x. We took 10, it's fine. We are now going to use any other value, let's say 30. You see the 30 is also on the points. Let's say 30 and see what will we get. Now we substitute x now with 30 on our equation. 30 for x, good. And I go back to my calculator. I go back, I say there. I don't delete the whole thing, the calculator, I just go to the brackets. And then on the brackets for x, I put in the 30, substituting x with 30. Then I say is equals to, my calculator say 119.668, I think is 119.68. Now when we draw the line, we are using those 2 points. I'm trying to get my ruler here. And then 10 give me 60.33, here 60, 10, 10, 10, say 60.33, here 60.33, there it is 60, 10, and 30, 119, 30, 30, 30, says 119, 110, 119, there, 119 somewhere there, can you see it? Right, then you have your ruler, there is your ruler, do you see your ruler there? Right, we draw the least squares regression line. There is our line. Our line then drawn, we use the equation, nothing else. We had to go to the equation. We had to come to the equation here. We substituted two values for this x on the equation, and these are the values we had to guide us on how will our line, least squares regression line look like. That is to be our least squares regression line. There is our line. Are you happy with that? I'm sure that answers that part of the question. Draw the line. Draw. Predict now. The question now says, predict the annual profit if the annual advertising expenditure is 25,000. The expenditure now is 25,000. 25,000. The expenditure 25,000. Right? 25,000. There we are. 25,000. It means we go now to our equation here. On our equation, what do we have now? For this x, we substitute in 25,000 here. For this x, we substitute in 25,000. Predict what will happen now in terms of the profit if the expenditure is 25,000. So it means in essence on your equation, y is equals to 30.65 plus 2.97 but 25,000. Do you see that? Now what we get there is 104 with your calculator. Please help me out. 850, but this is approximated value. It's no more that, it's approximated value. That is, it means the profit then will be around 104, 850,000. If the expenditure on advertising is 25,000, then it means they will have 104, 850,000 rand, 104,850 rand, 1,000 rand. Yes, there it is. Right? Are we happy with that answer there? Good. Predict. Now we have predicted, so we have the value there, 104,850 rand. Right? 104,850 rand. They are. We have predicted. We use the equation to actually predict the annual debt. Now, question 5. Look at question 5. It's very clear now. Says calculate the correlation coefficient. Remember, correlation coefficient is two values. I want to put back our notes on the screen here. Correlation coefficient is described by two values. It must be two values. Don't forget that. And very important, it has to tell whether positive or negative. It must tell whether positive or negative. That's important. That's important, and we're going back to our scatter plot. Look at the scatter plot. Already we look at the scatter plot, check with the person next to you, is this positive or is it negative? Right, we agree it is positive. Good. We come to the calculator now. We say AC on the calculator. We say shift 1 stats, and therefore we go to 5 regression, and there is R. Can you see 3 is R? We go 3, which is R, correlation coefficient is equals to, it says 0.95. My calculator says 0.95. I want to write that down. 0.95. I've got very faint colors here. Let me try this blue. R 0.95. That is R. R is 0.95. But what did the question say? The question says calculate that R. Calculate R. Just calculate it. Now to calculate R, we just went straight to the calculator, and our calculator gave us R. R is 0.95. We are happy about that answer. 0.95. We have just calculated. I want to go back to the question so that you can see the question. So this is the answer for 5.5. Calculate the correlation coefficient. So when you calculate it, there it is. Your calculator gave you a 0.95. Now the last question, I'm sure you guys are doing very well as well. The last question, what conclusion can you reach about the strength now of the association, of the relationship between the annual profit and the annual advertising expenditure? What conclusion can you make about the strength now? It is the next question. What conclusion can you make about the strength now? And we have agreed that when you look at your scatter, I want us to go back to the scatter. When you look back at your scatter, already we can see it's a positive association. The way our scatter looks like, it's a positive association. Our least squares regression line can tell us that as well. Now it is 0.9. 0.9. Positive 0.9. Now on our notes, when you check 0.9, it says strong positive association. Can you see that? Already positive, we could see it. Now it says strong positive. It means your answer then is we have a strong positive correlation here between the question. Let's go to the question. Between the annual advertising, expenditure. Oh, my pen. Annual advertising expenditure and the annual profit. Annual profit 0.9. It means now we have a very strong, there we are. Our answer now 0.95, a very strong positive correlation. Positive, we can see it from the scatter plot here. You see the gradient of our line is positive correlation, strong positive correlation because of 0.95, strong positive correlation between the annual advertising expenditure and the annual profit. Good. I'm sure we are happy about that. And there it is. Good. We are safe with anything more than 10 marks, which we can't afford to miss step by step. Take note there, the exemplar paper 2008. That question paper, I'm sure your teachers have got it. You can go through it again. 2008, your teachers know better. It was paper 3, but it's fine with you. Maybe we should actually go to this other paper here. Exemplar paper for this year. Exemplar paper for this year. Good. This is the exemplar paper for this year. 2014 exemplar paper. Your teachers have got a copy of this paper. Look at the screen. Your teachers have got a paper of this, a copy of these papers. Please ask it from your teachers. You need to work on it, look at it, and so forth. It is not only this question, so are many other questions that we will be discussing. They will also be coming from this exemplar paper because we use a number of papers to work on these exercises. There is a question again. Maybe we want to know is question what? Question 1, exemplar. Just the very first question, question 1. Let's read it. I don't want us to rush in answering question. We need to understand first what is written there. Let's read it. 12 athletes trained to run the 100-meter sprint event at the local athletics club trials. Some of them took their training more seriously than others. Some of them trained very, very seriously. The following table and the scatter plot show the number of days that an athlete trained and the time taken to run the event. The time taken in seconds is rounded to 1 decimal place. Number of days of training. The first athlete trained for 50 days. 50 days training for 100-meter sprint event. And that athlete, when running the 100-meter, the athlete took 12.9, I'm sure it's in seconds, 12.9 second. Time taken, 12.9. Very important, it is 2 sets of data. Do you see that? It must be number of days and time taken. And we already said when you draw, number of days is what? Is for the X, the horizontal line. And time taken is for the Y-axis, kind of the vertical line. But fortunately, in this question, the scatter plot is drawn already. It is drawn. There it is. It is drawn already. 70 days, the athlete took 13.1 seconds. 10 days, 17.0. 60 days, and so forth and so forth. Look at that. And now, here is the scatter plot drawn. Are we going to draw a scatter plot? No. It is drawn already. Look at that scatter plot. Look at the scatter plot. Number of days. You see, if an athlete train, I don't know if you can realize that, if an athlete train, for instance, 10 days, the athletes run for a very long number of seconds, 17 seconds. Do you see that? But if an athlete trains for 100 days training seriously, look, the athlete only takes 10.2 seconds. So when the athlete trains for few days, you run for a long time. But if you train for too many days, you take very short to complete your race. I don't know if I said that simpler to everybody to can understand. If you train for few days, only 10 days training, 10 days, look how long do you take? 17 seconds. But if you train for 100 days training, serious training, the athlete only took 10.2 seconds. So the more days you take to train, the few seconds you are going to run. 1, 2, 3, you are finished running your race. Do you see that? But if you train few days, when other people go to train, you don't train. Then look, you take too long time to complete the race. You are not fit enough. Can you see that? I'm sure that also relates to our studies today. If you take a lot of time on your schoolwork, if you work, you really will reap the benefits. You see, you'll get the correct answers, you'll get people to assist you. But if you only spend a little time on your schoolwork, obviously the result won't be very good. You see that? But if you put a lot of time, a lot of work on your studies, you'll get a very good result also come in. I know of students who sometimes send me WhatsApp questions very late in the evening at 11, at 12. They are still working on answering questions. You know, they work a lot of time. They are on their schoolwork. You will see the results. Surely the results will come. And get assistance. Ask for assistance. A lot of you, I know you check with your teachers, you check with your sub-advisors, you check with me, those who've got my numbers. They send questions, we talk about the questions, they answer those questions. They work a lot of time on their schoolwork. The results will come. This is what is happening as well here. Are you happy with that scenario there? I'm sure it's fine. We understand it. More days, little time that you take to run, because you have trained for many days. But if you only train for 10 days, you run for a long time running. Others have long finished. You are still running because you are not fit enough. Good. Let's go to the questions now. The first question says, discuss the trend of the data collected. We have talked a lot about it already. Discuss the trend of the data collected. I'm sure you have talked about it already. I don't know if you really want us to really write that down, but we have talked about the trend already. Maybe we can check our screen here. Discuss the trend. Are you in agreement? Can we agree that as the number of days the athlete used to train increase, the time taken to complete the race becomes very, very little? You can write it in any way. If my pen is not very clear. If an athlete train for many days, the athlete, let me check for another pen. The athlete takes little time to complete the race. The race. Ooh, my pen. Good, I'm sure it's clear enough. To complete the race. In any way you can write it. As the number of days athlete used to train increases, when the number of days increases, let me just write this as another way. When number of days increases, to train increases, time taken decreases. Time taken to run decreases. Right. Whatever way we can write it, it's fine. I don't have very nice colors here to write. They are running dry. Good, that's better. When we have too many days to increasing to train, then the time taken decreases. I'm sure you are happy with just to discuss the trend. It's 1 mark thing. And you can see it from this table here that when the number of days increases, the time also goes down. It decreases. Thank you very much. At least I have a better pen to write here. Right. Identify any outliers in the data. Now on the scatter plot, it becomes easy for us to identify the outlier. Here is the outlier. Can you see the outlier? So we can write that your outlier there, 60 and 18.1. Look at the outlier. The outlier 60, do you see 60? And 18.1. It's not really on 18. It looks like it's a little bit above 18. Can you see that? That is the outlier. When you look at this set of data, look at a set of data there, but there is an outlier there standing alone. There is the outlier. Good. Are you happy with that outlier? So you write the outlier and say that is the out. At 60 and 18.1, we have the outlier there. You write that answer there. The other question says, calculate the equation of the least squares regression line. Calculate the equation. Calculate the equation. Remember the equation. You write it. It is y. The equation is y is equals to a plus bx. The equation y is equals to a plus bx. It needs us to go to the what? To the calculator. I want us to repeat that process again. Calculate the equation of the least squares regression line. We need the information on the calculator. Please, let's work together. My calculator is ready. It's on. Right. I'm going to put in the values here. I say mode and 2 and then 2 again. I'm sure you can see x and y columns. Do you see that? I start first with x. It's 50 is equals to 70. Please help me out. We cannot afford to miss any number. 10 plus, is equals to 60 is equals to 60 again. And then we have 20 and then it's equals to 50. Is equals to 90, is equals to 100. We are repeating this process again. 60 is equals to 30 and 30 again. I hope I have all of them. They look like they are 12. I want to check on the table if we have 12 numbers there. I'm counting from the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12. It looks like my calculator. I've inserted everything in the calculator. Now I'm on the y column, 12.9. I'm sure you are doing that with me. 13.1. No. Let me start again. I made a mistake here. It's 12.9 is equals to good. 13.1 is equals to 17 is equals to 11.3 is equals to 18.1 is equals to 16.5 is equals to 14.3 is equals to 11.7 is equals to 10.2 is equals to 12.7 is equals to 17.2 is equals to 14.3 is equals to. I've got all set of data in the calculator. I go AC, shift, 1 is statistics and 5 is regression. Already gives me A and that and that and that. Now I must write the value of A now here. We must now write the value of A, and at least we must agree. 1 is A. I say is equals to. Now my A looks like A is 17.81931464 plus AC shift 1. I go 5 again, and then B is 2. B looks like it's negative 0.07068535826. So the equation, therefore, because the question, now we go back to the question to make sure, calculate the equation. Calculate the equation. The question said calculate the equation. This is the value of B from the calculator, the value of A from the calculator. The equation 17.81931464 minus, you remember it is supposed to be plus BX. Now but B here is negative. So minus 0.07068535826x. Do you remember that? A plus BX. Good. Now the equation corrected to 2 decimal places, 82 minus 0.07x. That becomes the equation. I'm sure I'm sure we are following each other very well. The equation now corrected to 2 decimal places, a minus b. It is minus because look at the value of b. The calculator that I have here says a minus. And we agree with the calculator because already when you look at a set of data here, you see it's a negative association. Look, negative. Can you realize that? Remember we said it becomes positive if the set of data goes a little bit up kind of thing. But now it is this way. Now it becomes a negative gradient. Do you realize a negative gradient? So we have the equation there. And the other question says predict the time taken to run 100-meter sprint for an athlete training for 45 days. Athlete training for 45 days. 45 days. 45. Predict, because we use this equation, remember, the line, we use this line to predict 45 days. Now it means predict athlete running for training also for 45 days. Then when you predict for that athlete, I don't know, maybe it's number 4, y is equal to 17.82 minus 0.07. Now our x here is how much? 45 days. Do you see that? Now we go to our calculator. I press 17.8 that 9314, trying to be as accurate as we can. 0 point on the calculator, 07 68 53 58 26, but the x now is how much? 45 days. Then we say equals to approximately that athlete will take 14.36 seconds. That athlete will take approximately 14.3. I'm looking at my calculator. I hope my calculations are fine. Please check with me that side. At least comment on the strength of the relationship. You see number 6 now. Comment on the strength. This was number 5. Comment on the strength of the relationship. In fact, number 5 said first. I skipped the first one. Number 5 first said, calculate the correlation coefficient. What do? We still just go back to our calculator. Already remember we have done this information. We say AC on the calculator, shift state. And we say 5 is regression, R is 3. Can you see R appearing on the screen? Is 3 is equals to. So our R, we write therefore that R is equals to negative 0.74. Calculate. The question said calculate the correlation coefficient. Good. Calculate the correlation coefficient. We have just simply calculated it there. And the last question, number 6, calculate the correlation coefficient. Now number 6 is comment on the strength of the relationship between the variables. Now already we agree. The gradient was negative. We can see here it's a negative association. Do you see the set of data here? It's a negative association. Can you realize that? Good. Now once it's a negative association, we check on our notes just to make sure. Comment on the strength. Comment on the strength. Now negative 0.7. Negative 0.7. Here we are. It's a strong, what? Strong negative. Strong negative association. Strong negative association. Are you happy with that? Then we can write there that strong negative association between the months taken to between the number of days of training and time taken to run the race, to run or complete the race, complete the sprint or the race. Good, sprint. All right. But very important, 2 words: strong negative. Negative or positive, those 2 words must be there, either positive or negative, and then you indicate then the association, whether it is strong, whether it is moderate, whether it is perfect, whether it is weak or no correlation. Please you indicate those. Right. I'm sure we have done fairly well on that question. There are a number of questions. I thought we'll have time also to talk on the other question, which is, I'm sure, on 2013 March paper, 2013 March paper, but I'll just write it simply here. But all other questions, please talk to your teacher. 2013 March paper, February paper, 2013. There's a very nice question again about regression there and the scatter plot. Please look at it. And all other questions have got this same kind of question. Your teacher should be able to assist that. They can phone to get assistance from the subject advisors or the schools or any other source. There is an SMS here that needed me to talk to. I want us just to quickly look at it, but in the meantime, I'll show you this question on the screen, because as we are talking here, you colleagues, which is very good. Right. There was a request to repeat the drawing of the line of best fit. The drawing of the line of best fit. As to how do we draw the line. Good. I'll just use what we have done already. I can't remember very well which question was this one, but let's try to use what we have drawn already to see if it will help us with the line of best fit. Because the question was, can you please try to repeat the line of best fit? Yes, I'm sure this is what we did before, right? Now, once we have the equation, look at the equation. The equation comes from AB, remember, from the calculator. This is the equation. Am I right? Good. I want to indicate it here that this is your equation. It comes the value of A, the value of B, there's substitution A, B, you substitute them, but there's X there, BX, BX. Can you see that? This is your equation. Corrected to 2 decimal places, BX, there it is, good. Now the question now, if it says draw the line, because remember you have the scatter plot, but you don't have the line. Now to draw the line, we take any value here on the x-axis here, value of x, so we can take any value, maybe 10. You see 10. I'm taking 10. Now I take 10. When I substitute 10 here for x, remember that 10 comes from x, axis. When I substitute 10 for x here, when I substitute 10, the y here now, y is equals to 60.33 on the calculator. When you put 10 on your equation, substitute 10 for x, then now y becomes that. And you do the same thing, you can take any lower value on a scatter plot and any upper value, you know. You can even take 25, for instance. 25, I took here 30, the value 30. Now when you take 30, for this x here, you substitute now 30 for the second point. 30 here, you write 30 here. On your calculator, it's in bracket 30. You write everything as it is, 30 in brackets, right? Now it will say y is equals to, y is 119.68. Do you see that? So to draw the line, you have those 2 points. To draw the line now is what? It is, how do I do this? Let me see this way. To draw the line now, remember, where are we now? Right, remember now, let me go a little bit up. Remember now that 10, at 10, we had 60.8. When we substituted 10, we had 60. Do you remember that? 10 gave us 60. But when we substituted 30, for instance, we had 190. There it is. 30 went with the 119. 119 for y. These are the 2 points. We calculate them with the calculator. These are the 2 points. 10, 60.33. 30, 119.68. Then the 2 points, you draw the line on the 2 points. That you have substituted here on the equation, in the equation for the value of x. That is basically how we draw, but I hope your teachers can take this further, but do a lot of practice. Especially the calculator skill. Keep your own calculator, and you need to do more and more, a number of exercises of this similar nature. Understand the association as explained by a correlation coefficient. When is it no correlation? When is it perfect? Whether negative or positive? When is it strong? When is it weak? whether positive or negative. Please remember that it's very important. It is always two ways, either negative or positive, and then you put whether it is a strong, weak, moderate, or whatever way. But those two ways are very important to explain the correlation coefficient. My children, thank you very much. It's been very, very nice. I hope you will take this and you practice a lot of exercises with the calculator on this work. Thank you very much. I really, as we continue to practice, to prepare ourselves for the trial examination, wish you well that please concentrate on your work. This is a very important time of the year for you. You're going to do very well, I'm sure, but you yourself know very well that the more time you spend on a schoolwork, the more the good results will come for you. Thank you very much. I hope to see you again in future. Thank you. Bye-bye.